Welcome to this comprehensive educational video where we'll explore how to find the volume of a cube. This fundamental concept in geometry will open doors to understanding three-dimensional space and has countless real-world applications. A cube is a special three-dimensional shape that you encounter every day. Think of dice, ice cubes, or building blocks. But what exactly makes a cube unique? A cube has very specific properties that make it special. It's a three-dimensional shape with 6 equal square faces, 12 edges that are all the same length, and 8 vertices or corners. Understanding cube volume is incredibly useful in real life. Whether you're calculating storage space in boxes, determining material needs for construction projects, or solving problems in science and engineering, this skill is essential. In this video, you'll master the volume formula and understand exactly why it works. We'll walk through step-by-step calculations, solve multiple examples of increasing complexity, and explore real-world applications that make this knowledge practical and valuable. By the end of this video, you'll have complete confidence in calculating cube volumes and understanding their practical applications. So grab a pencil and paper and get ready to master this fundamental geometric concept. Before we dive into calculating the volume of a cube, we need to understand what volume actually means. Volume is a fundamental concept in three-dimensional geometry. Volume refers to the amount of space that a three-dimensional object occupies. Think of it as how much room an object takes up in the real world. To visualize this concept, imagine filling a container with water. The volume would be the total amount of water that fits inside that container. Now that we understand volume, what exactly is a cube? A cube is a very special three-dimensional shape with unique properties that make volume calculations straightforward. A cube is a three-dimensional solid that has 6 faces, and each face is a perfect square. All of these square faces are exactly the same size. A cube has several important properties. It has exactly 6 square faces, 12 edges where faces meet, and 8 vertices or corners. The most important property for volume calculation is that all sides of a cube are equal in length. This means every edge has exactly the same measurement. We use the letter S to represent the length of one side of the cube. Since all sides are equal, knowing just one side length tells us everything we need to know about the cube's dimensions. This equal side property is what makes calculating the volume of a cube much simpler compared to other three-dimensional shapes like rectangular prisms or cylinders. Understanding these fundamental concepts about volume in cubes gives us the foundation we need. In the next section, we'll discover the elegant formula that uses these properties to calculate a cube's volume. Now we arrive at the heart of calculating cube volume, the fundamental formula. The volume of any cube can be found using a simple but powerful mathematical relationship. This formula, V equals S cubed, tells us that volume equals the side length multiplied by itself 3 times. The V represents volume, and S represents the length of any side of the cube. But what exactly does S cubed mean? The exponent 3 tells us to multiply the side length by itself 3 times. This represents length times width times height. Since a cube has all sides equal, we multiply the same value 3 times. This is why we use the exponent notation S cubed. Here's a concrete example. If our cube has a side length of 4 units, we can calculate its volume step by step. We start with our formula, V equals S cubed. Substituting our value, we get V equals 4 cubed. This means V equals 4 times 4 times 4. Calculating this multiplication gives us 64 cubic units. Notice how we always express volume in cubic units, such as cubic inches, cubic feet, or cubic centimeters. To visualize this result, imagine our cube filled with 64 smaller unit cubes. Each layer contains 16 unit cubes, and we have 4 such layers, giving us our total of 64 cubic units. Remember, this simple formula V equals S cubed is all you need to find the volume of any cube. Just cube the side length and express your answer in cubic units. Now we'll work through our first example step by step. We have a cube with a side length of 5 centimeters, and we need to find its volume. Here we can see our cube. Each side has a length of 5 centimeters. Notice that all edges of a cube are equal in length. This three-dimensional shape has 6 equal square faces. We can rotate it to see that all sides are indeed the same length. Remember, the formula for the volume of a cube is V equals S cubed, where S is the length of one side. Now we'll substitute our known value into the formula and calculate the volume step by step. Step 1, we substitute S equals 5 centimeters into our formula. This gives us V equals 5 centimeters cubed. Step 2, remember that cubed means we multiply the number by itself 3 times. So 5 centimeters cubed equals 5 centimeters times 5 centimeters times 5 centimeters. Step 3. Now we calculate the multiplication. First, 5 times 5 equals 25. Then we multiply 25 times 5, which equals 125. Step 4. Our final answer is 125 cubic centimeters. Notice that we include the units, cubic centimeters, because volume is always measured in cubic units. This works because volume measures how much space the cube occupies. By multiplying length times width times height, which are all 5 centimeters for a cube, we get the total space inside. Remember, always include the correct units in your final answer. For volume, we use cubic units like cubic centimeters, cubic meters, or cubic inches. Now we'll work through our second example, which involves a cube with a decimal side length. This will show you how the volume formula works perfectly with non-whole numbers. Here's our problem. Find the volume of a cube with a side length of 2.5 meters. Notice that this time we're working with a decimal value rather than a whole number. Here's our cube with a side length of 2.5 meters. I'm highlighting this measurement in orange because it's the key value we'll be using in our calculation. Let me rotate this cube slightly so you can see that all sides are equal, each measuring 2.5 meters in length. Remember, the volume formula for a cube is V equals S cubed, where S is the length of any side. Step 1. We substitute our side length of 2.5 meters into the formula, so V equals 2.5 meters all cubed. Step 2. Remember that cubing a number means multiplying it by itself 3 times, so 2.5 cubed equals 2.5 times 2.5 times 2.5. Step 3. We'll calculate this step by step. First, let's multiply 2.5 times 2.5, which equals 6.25. Then we multiply our result, 6.25, by the remaining 2.5. This gives us 6.25 times 2.5 equals 15.625. Therefore, the volume of our cube is 15.625 cubic meters. Notice how we include the cubic units, meters cubed, in our final answer. This example demonstrates an important point. The volume formula works exactly the same way, whether you're dealing with whole numbers or decimal values. The mathematical process remains consistent. As we can see from our rotating cube, this volume of 15.625 cubic meters represents the total amount of space contained within this three-dimensional shape. This completes our second example. We've successfully calculated the volume of a cube with decimal side lengths using the same reliable formula. Sometimes you might encounter a problem where you're not given the side length of a cube, but instead you're given the diagonal. In these situations, we need an alternative method to find the volume. The diagonal of a cube is the straight line distance from one corner to the opposite corner, passing through the interior of the cube. This is different from the edge length we've been using. When we know the diagonal length, we use this special formula. V equals the square root of 3 times d cubed, all divided by 9. This formula comes from the geometric relationship between the diagonal and the side length of a cube. Now let's work through a concrete example to see how this formula works in practice. Here's our example problem. We have a cube with a diagonal length of 3 inches, and we need to find its volume. Step 1. We start by writing down our diagonal formula. Step 2. We substitute our given diagonal value of 3 inches into the formula. Step 3. We calculate 3 cubed. 3 times 3 times 3 equals 27. Step 4. We simplify the expression. 27 times square root of 3 divided by 9 equals 3 times square root of 3. Converting to decimal form, this is approximately 5.196 cubic inches. This diagonal method is particularly useful when you're given the diagonal measurement instead of the side length. It's common in engineering problems or when measuring existing objects where the diagonal is easier to measure than individual edges. Now that we understand how to calculate the volume of a cube, we can explore how this mathematical concept applies to real-world situations that you might encounter in everyday life. Our first application involves water storage. Imagine you work at a water treatment facility and need to fill a cubic water tank. Understanding the tank's volume helps determine exactly how much water is needed. This cubic tank has sides measuring 8 feet each. To find how much water it can hold, we need to calculate its volume using our formula V equals S cubed. We substitute 8 feet into our volume formula. V equals 8 cubed, which means 8 times 8 times 8. Calculating step by step, 8 times 8 equals 64, and 64 times 8 equals 512. Therefore, the tank holds 512 cubic feet of water. Now we move to a construction application. Construction workers often need to calculate concrete volume for cubic foundations or structures. Consider a construction project where workers need to pour concrete for a cubic foundation. The foundation measures 6 meters on each side. Each side of this foundation measures 6 meters. To determine how much concrete to order, we calculate the volume using V equals S cubed. Applying our formula V equals 6 cubed. This means we multiply 6 times 6 times 6. Working through the calculation, 6 times 6 equals 36, and 36 times 6 equals 216. The foundation requires 216 cubic meters of concrete. Our final example involves shipping and storage. Companies often use cubic containers to maximize storage efficiency and calculate shipping costs. A shipping company uses cubic storage containers that measure 4.5 feet on each side. They need to know the storage capacity to price their services correctly. Each side measures 4.5 feet. Notice this involves a decimal number, but our volume formula works the same way. V equals S cubed. Substituting into our formula V equals 4.5 cubed, we calculate 4.5 times 4.5 times 4.5. Computing step by step, 4.5 times 4.5 equals 20.25, and 20.25 times 4.5 equals 91.125. The container holds 91.125 cubic feet. These real-world applications demonstrate why understanding cube volume is essential. Whether you're working with water storage, construction materials, or shipping logistics, the same mathematical principle applies across all these practical situations. Now that we've explored the volume of a cube through various examples, it's time to discuss some essential tips and common mistakes that will help you master this concept. First, here are 4 essential tips that will ensure you calculate cube volumes correctly every time. Tip number 1. Always ensure all measurements are in the same units before calculating. This is the most common source of errors in volume calculations. Tip number 2. Always double-check your calculations, especially when cubing numbers. Small arithmetic errors can lead to significantly wrong answers. Tip number 3. Remember to express your final answer in cubic units. Volume is always measured in 3-dimensional units, like cubic centimeters or cubic inches. Tip number 4. Always try to visualize the cube you're working with. Understanding the 3-dimensional nature helps you grasp why we cube the side length. Now, let's examine the most common mistakes students make when calculating cube volume and how to avoid them. The first common mistake is mixing units. If your side length is 2 feet, don't convert to inches partway through the calculation. Keep everything in feet and get 8 cubic feet, not 8 cubic inches. The second mistake is forgetting to cube the side length. Some students multiply by 3 instead of cubing. Remember, volume equals S cubed, not S times 3. The third mistake is using linear units instead of cubic units for the answer. Volume must always be expressed in cubic units, like cubic meters, not just meters. Now that we've covered the essential tips and common mistakes, let's conclude with a final review of what we've learned. The volume of a cube is found using the simple but powerful formula V equals S cubed, where S is the length of any side of the cube. By following the tips we discussed, avoiding common mistakes, and practicing with various examples, you can confidently calculate the volume of any cube you encounter. Thank you for watching this comprehensive guide to finding the volume of a cube. I hope this video has helped you understand this fundamental geometric concept. If this video helped you understand cube volume, please give it a thumbs up and subscribe for more math tutorials. Feel free to leave any questions in the comments below, and don't forget to check out our other geometry videos to continue your mathematical journey. Remember, mathematics is all about practice and understanding. Keep working with these concepts and you'll master them in no time. Thanks for watching, and I'll see you in the next video.